So we begin with the next chapter here, which is system of particles and rotational motion. And in this chapter, in this first section, we'll focus only on system of particles. And the first topic from which is center of mass. Okay, beginning with this question. It's a very recent one, 2024. So what I'll do is for this first question, and almost in every possible question that are coming up, wherever it's required. Okay, I'll try to cover the question in three different ways. One, we'll do it in a very short way, which will not have any detailed explanations and will have only direct calculations. Second part, wherever there it is necessary, I would make sure that the concept is explained. So in this case, we'll try to go in detail with this word uniform section. What is the relevance of, what is the significance of this word uniform section? And the third part, we will discuss the detailed solution. Okay. So if you are okay with the direct calculation, maybe you can just write down the note and then just move to the next question. But if you feel that much clarity, or deeper explanation is required, you can go to the third part of this. Okay. So this is part one. We'll go to the direct calculations. So we have 1, 2, and 3. I'll try to summarize everything here. So first is uniform thin metal. So uniform thin metal, what does it imply? It implies equal mass distribution, which means in a uniform plate, the mass density, which is mass density equal to mass per unit area, is constant throughout. Which further means that if you take any two sections of the plate with the same area, they will have the same mass. Okay. Let us try to understand this explanation first, and then we'll go through the example. So when we say that the mass density, which is actually mass per, so we have sigma is equal to mass density, which is mass per area. Now in a uniform plate, this mass density, which means mass density sigma, is constant throughout. So if I consider one plate and if I divided it into four equal halves, say for instance 4 equal halves, and then assign individual mass densities for them, say sigma 1, sigma 2, sigma 3, sigma 4, then we have sigma is equal to m by a, then sigma 1 will be equal to m1 by a1, correspondingly sigma 2 will be equal to m2 by, my bad, this should be equal to m2 by a2, similarly m3 by a3 and m4 by a4. Now if the plate is uniform, then sigma is constant throughout, which means sigma 1 should be equal to sigma 2, and likewise with sigma 3 and sigma 4, right? And if we consider sigma 3 and sigma 4 alone, what can we say? If sigma 3 is equal to sigma 4, then m3 by a3 should be equal to sigma 4, which is m4 by a4. And if this condition is true, m3 by a3 is equal to m4 by a4, then if we impose another restriction here, which is if a3 is also equal to a4, then it becomes clear that m3 should be equal to m4. Therefore, it means that if you take any two sections of the plate with the same area, a3 is equal to a4, they will have the same mass, m3 is equal to m4, when the mass density sigma is a constant throughout. Okay, so that is the significance of this word uniform plate. Now if we assume this plate to be a plate of 8 kilogram mass, then every 1 meter of the plate weighs 1 kilogram, or in other words, no part of the plate is heavier or no part of the plate is lighter than any other part of the same size. Size is important. So if this is 8 kilogram plate, it simply means that this part should be 1 kilogram, 1, 1, 1, making it sum up to 8. Okay. Now, if I were to consider this plate in a different, in a different manner, say for example, if I consider this as 1 unit, okay, maybe I'll just draw it more fairly. So say this is 1 unit, unit 1, okay, and then we have another unit which is unit 2. Come on, and all these of course, for examples, right? And we have third unit like this. And so this is the fourth one. In this case, what should be the mass distribution? It should be exactly, it should be like this. Make a guess, it should be 2 plus 2 plus 2, right? Why? Because this complete mass is divided into 4 equal parts, and every meter square will have 1 kilogram. And this goes for example, okay? We're just assuming that it is 1 meter, so 1 kilogram per meter square. We're just assuming it to be. So if the density is given to us as 1 kilogram per 1 meter square, then this logic holds. Okay, right. Now, if you're clear with this part, let us now go directly into the calculation of center of mass. So what I've done is I've divided this complete figure into 3 different areas: area 1, area 2, and area 3. First, we will consider the calculation for area. First, we'll consider the calculation for area 1. Okay. Now, for area 1, the center of coordinate, the coordinate of center of mass is C1, which is x1, y1. And we know that x1, y1 is equal to, this distance is 3, this distance is 1. So if I have to write this, so we have this much of length is 3, and this length here is 1. And therefore, the coordinate of center of mass would be width by half and height by half, which is 3 by 2 and 1 by 2. And the mass of this area should be equal to 6 kilograms. Why? Would be equal to 6. Why? Because the complete mass is 10, which means this should be 2 plus 2, and this complete rectangle should be 6. Okay? Why? You can just divide it like this. Equal divisions will have equal area. So it will give me areas like this. 2 plus 2 plus 2, and if I combine that as one single mass, I'll get it as 6. Okay? Right. Now, so that's with the calculation of area 1. Now let's see what's the same calculation for area 2. So for area 2, which is highlighted here, right? Area 2, which is highlighted here, the dimensions of this area are 1 centimeter is the width, 1 centimeter is the height, and therefore the center of coordinate should be therefore the coordinates of center of mass should be 1 by 2 and 1 by 2. Then why do we have this plus here? We have 1 plus 1 by 2 because this is the center of coordinate of center of mass here, right? And every measurement we make should be made with reference to the origin, which means it is this far from the x-axis, right? And it is this much far from the my bad, to make it more correctly. So we have, this is the coordinate of center of mass, this is the y coordinate, which is equal to, see, this much distance is 1, this center of mass here is 1 by 2, so we'll have the coordinate as 1 plus 1 by 2, which is 3 by 2. Okay, and what about the x coordinate? The x coordinate is this distance over here, which is half of this, half of the width is 1, therefore this much distance is 1 by 2. Therefore for area 2, the coordinate of center of mass is 1 by 2 comma 3 by 2. Now if you do the same calculation for area 3, the coordinate of center of mass of this area is over here, right? Over here. Oops, my bad. And this is the coordinate of center of mass here. And how, with respect to the origin, how far is it? We'll have to calculate the x and y coordinate now. How will it look like? So say this much will be the distance of the x coordinate, right? Sorry, the y coordinate, which will be equal to, so let us say this much, what we have here is 1. half of height is 1 by 2. So the y coordinate becomes 1 plus 1 by 2, 1 plus 1 by 2, which is 3 by 2. Now, what about the x coordinate? The x coordinate means this distance, right? How much is that? Let us see. Up till this mark is 1. Up till this mark further is 1. So 1 plus 1 is 2. And this much length is half. So what we have is 1 plus 1, 2. 2 plus 1 by 2, which is 5 by 2. Right? Now, if you have any doubt, in the way I have calculated the center of mass and the coordinates, I have explained this in very much detail. You can follow the next, the coming solutions. Your concept will become very clear. See, I do understand that for one question it is taking somewhere around 10 to 12 minutes for the for the direct way, which I claim to be is not not detailed, and for the detailed explanation it will go somewhere around 15 to 30 minutes. But I assure you, if you spend that much time, only if you are here for the first time, if you're learning this concept for the first time, I can assure you that if you write down the notes with me, if you can write down the detailed solution with me, then every problem you do on your own, if you try to replicate the same method, things will become really clear to you. You will start feeling the confidence to solve these questions on your own. Okay, right. So now we have calculated all the three coordinates, and then we know that the coordinates of the center of mass of the composite figure will be x bar and y bar, where x bar is given by m1 x1 plus m2 x2 plus m3 x3, y bar being given by m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Okay. Now what is m1? 6. So this becomes 6 into 3 by 2 plus m2 is 2, 2 into 1 by 2 plus 2 into 5 by 2. Okay. Similarly, for the y coordinates becomes 6 into 1 by 2, 6 into 1 by 2 plus 2 into 3 by 2, 2 into 3 by 2 plus 2 into 3 by 2, 2 into 3 by 2. Denominator being m1 plus m2 plus m3, which is 6 plus 2 plus 2, which of course is ratio, would cancel out to give the answer as 1. Anyway, so now we have 6 into 3 as 18, 2 into 1 is 2, 5 2 is 10, so 10 plus 18 is 28 plus 2 is 30, 30 by 2 is 15. 6 plus 6 is 12 plus 6 is 18, 18 by 2 is 9. So we have x bar is equal to 15 by 10 and y bar is equal to 9 by 10. And when you divide these two, what you get is x bar by y bar is equal to 15 by 9. And according to the question, the ratio of the x and y coordinates given to be is equal to n by 9, which means the value of n should be equal to 15. Okay. So like I said, if you have any problem, if you have any difficulty in understanding the calculation, the way to arrange the center of mass individually and then to find out the composite way, please go through the next set of questions, the next set of solutions. Things will become really clear to you. Yes, it may take somewhere around half an hour for one complete question, but if you spend that, I can assure you it will be worth improving your confidence, and you will see that in your coming solutions when you do it on your own, of course. Okay. So yeah, now let's try to understand what is the significance of this phrase uniform section, which is very important. It is not important for your numericals, but these kind of concepts are important when it comes to assertion reasoning, and of course, which acts as the very base for JEE Advanced. All right. Okay. Now moving on to the next part of the solution.